Hello everyone, welcome to the sessions of computational mathematics. In our previous sessions we discussed few operations on the sets. In this session we are going to discuss some of the algebraic properties on set operations. So the algebraic properties of set operations are like this: commutative law, associative law, distributive law, identity law, complement law, idempotent law, domination law, absorption law, De Morgan's law, double complement or involution law, complement law for the universal set and the empty set. Let's see each of the property here. Commutative law, which defines that A union B is equal to B union A. Similarly, A intersection B is equal to B intersection A. Both are equal. Next, associative law. A union B union C is equal to A union B union C. Similarly, with respect to intersection, A intersection B intersection C is equal to A intersection B intersection C. Next is our distributive law. A union B intersection C is equal to A union B intersection A union C, and A intersection B union C is equal to A intersection B union A intersection C. Next is identity law. If we perform union operation between a set and a null set, it will give the null set itself, that is A union null set is equal to A. Similarly, if you perform intersection operation, A intersection U, then universal set, U means universal set, which yields A only. Next is complement law. A union A dash, that is complement of A, is equal to, it gives rise to universal set, and A intersection A complement give rise to null set. Next is idempotent law. A union A, which is nothing but our A. Similarly, A intersection A is A itself. Next, domination law. A union universal set, which gives universal set itself, and A intersection null set, which gives null set itself. Next, absorption law. A union A intersection B give rise to A. Similarly, A intersection A union B give rise to A itself. Next, De Morgan's law, we call it as also negation law. A union B whole complement is equal to A complement intersection B complement. Similarly, A intersection B whole complement is equal to A complement union B complement. Next is double complement or involution law. Complement of complement A give rise to A itself. So complement get cancelled, that we do. So it give us back the A itself. Next, complement law for the universal set and the empty set. If we complement null set, it gives universal set. If we complement universal set, it gives null set. Let's see a few problem on it. If A is equal to 135, B is equal to 356 and C is equal to 137, verify that A union B intersection C is equal to A union B intersection A union C. This is our distributive law. So, we can solve this by taking LHS and RHS separately. If we take LHS, A union B intersection C. So, first we have to find B intersection C. B intersection C means common elements of B and C, that is 3. Therefore, B intersection C is 3. Next, we have to union this with our set A. Then 1, 3, 5 and 3. So, therefore, it gives 1, 3, 5. This is the resultant set of this LHS operation. Next, if we perform the RHS operation, first we have to find A union B. That is, A union B means elements belongs to both A and B. That is 1, 3, 5 and 6. So, 1, 3, 5, 6. Next, A union C. 1, 3, 5 and 7. 1, 3, 5 and 7. If we take the intersection of these two, the common elements are 1, 3 and 5. Therefore, 1, 3, 5. Therefore, from equation 1 and 2, we can say that the sets are equal. That is, LHS is equal to RHS. Therefore, A union B intersection C is equal to A union B intersection A union C. So this is how we can solve the problems on set. Next is string. So these are the applications of sets in our computer science. So what is a string? A string is a finite sequence of symbols from the alphabets. Let sigma be the non-empty set of symbols called the alphabet. For individual symbols, we construct strings over sigma. The empty string epsilon is a string with no symbols at all. Any set of strings over the set of alphabets is called as a language on the alphabet. We can see an example for our string here. Let sigma is equal to C. This is the alphabet that is defined by this. Then L1 is equal to CC, represents one string, and similarly L2 represents C, CC, CCC, represents a type of a string. Next L3 is another type of string, which is a word such that W is equal to C power K. That is where K is equal to 0 to infinity. So which is equal to epsilon, that is null string, C, CC, CCC and so on. Here L1 and L2 and L3 are the set of strings which comprises the language. This is one of the application of our set in computer science. Next is regular expressions. A regular expression is a special sequence of characters that helps you to match or find other strings or set of strings using a specialized syntax held in a pattern. They can be used to search, edit or manipulate text and data. It is used in all the programming languages like C++, Java and Python. And some of the regular expressions are very useful for programmers and can be used for a variety of tasks such as searching for a string, implementing a find and replace function, and validating user input. Example, we can validate email addresses or passwords while logging into some accounts. So here we make use of regular expressions in so many applications. So this is about the regular expressions, which is also an application of sets. So in this session we discussed some of the properties of set operations and string and regular expressions along with the examples. Thank you.